Hello everyone, good morning. Hello. Hello everyone, how are you all? Sudeshna, so much Insta done. Spidey, Naruto friends are there. Good morning everyone. Vardhan, good morning. How are you all? All good. So, classes going on. So in the last class, what we have studied? In the last class, we have done the basic part and we have done that Z effective. So those who have missed the last class, those who have missed the last class, they can watch the video. These videos are online available, so you can watch the video. Those who have missed the last class, Z effective nuclear charge was an important topic. Effective nuclear charge was an important topic. We also told how to remember F block element. Very good. F block, how to remember F block element, and Z effective. Z effective was the most important point. Z effective was the most important point. Okay, periodic table also we get a brief idea. I told you also ki see in this time means those who are not very much familiar, they should see a periodic table 10 to 15 minutes daily ki which element is where and all. And we have also said ki if you are having any previous notes, then you can read your previous notes also. Okay. So if anyone missed, I will suggest you please see Z effective, because Z effective will come everywhere. Full periodic table they will use the word Z effective. ठीक है ना? Okay, Chaitu, Mohan Sai. Okay, so let's start. So in the last class I have written there, the last point which we were trying to write was Z effective in a period increases, correct? So last time we have written like this कि Z effective increases in a period, and if Z effective increase in a period, Z effective is pulling. And down the group we have not said anything. Down the group we are not interested much, but we can say like this कि Z effective down the group is almost constant, means, and this we are saying for S and P block, not for D block. Keep this in mind. For all block we are not saying this, we are saying for S and P block. Okay, na? So down the group we will not talk about Z effective much. We are mainly interested in Z effective in a period. Okay. So we have also said yesterday in last class that Z effective increases, pull increasing. So if Z effective increasing, size will contract. Nucleus is attracting the new electrons, size will contract. Okay, na? So from here we will jump to this point, that is your radius, atomic size, जो भी बोल लो. ठीक है ना? So radius means what? कि one atom is there, you will say, sir, this is one atom, na? This is the center, this is line, this is R, radius done. Take a scale, measure it. हाँ? ऐसे बोलेगा? हाँ? Sir, a sphere is there. First, it is not a circle, it is a sphere. Atoms are spherical. Then second point is there ki it is not like a ball, big ball you can see, it is very small, not able to see with naked eye also. So radius calculation is not that easy. Radius calculation is not that easy. They say like this also ki exact radius cannot be measured. Exact radius cannot be measured. They are saying like this also. Why they are saying like this, bhai? They are saying exact radius cannot be measured because The boundary is not sharp. Boundary is not sharp. Boundary is not sharp. ठीक है ना? Now you will think, sir, what boundary? See, like this board is there. This board boundary is sharp. ठीक ना? You will clearly see here board ends. ठीक ना? You are having phone in your hand. Phone boundary is sharp. You will say, sir, here phone finishing 6.1 inches. ठीक है ना? Now this atom electrons, we say electron cloud. Electron is like what? Cloud. Now when you see a cloud, while drawing, so you draw in childhood, sir, cloud we make like this, sir. Cloud, birds are there. Okay, na? So cloud, when you see any cloud, you cannot define its last point. Okay, na? What is happening? Somewhere there is dense. As you move away, it fades slowly, lighter, and fades away. So exactly where it is finishing, you will not know this. Exactly where it will finish, you will not know this. Okay, so that's why boundary is not sharp, means slowly. I will give you live example. देखो इधर live example I am telling you from this board only. इधर देखो सब लोग. So when you see these color boxes, you can clearly see, sir, boundary is sharp. Arey, how sharp? Sir, red color, sir, only this much. See, sir, yellow color, only this much. Sir, purple color, only this much. So you will say like this, sir, green color, like this much only. ठीक है? So boundary is sharp in this. देखो देखो देखो, सुनो, boundary is sharp. But if there is one more thing ना. मान लो if I talk about this box, ये बॉक्स देखो एक बार, रेड कलर इज हियर. देखो यहां पे एवरीवन सी, रेड कलर इज हियर, दिस वन रेड. कैन यू टेल मी वेयर द रेड कलर इज फिनिशिंग? बताओ तो, वेयर दिस रेड कलर इज फिनिशिंग? कैन यू टेल एग्जैक्टली? बोलो भैया, can you tell? Or see, this is blue color. Can you tell from blue color exactly starting and exactly ending? Live example, bhai. No, because you are seeing, sir, blue color middle to dark, but slowly it is fading, gone. But you cannot tell till where. Blue and that pink color has overlap, na? Slight mixed. Here red is mixing with yellow. Till where exactly we don't know. So that means in this we don't have a sharp boundary. But in these cases we are having sharp boundary. In these cases we are having what? Sharp boundary. So this is sharp boundary. So we cannot measure exact radius. Then you will say, sir, then how? So we are saying, but exact bond length can be calculated. Exact bond length can be calculated. Exact bond length we can calculate. Okay? So now the question is, sir, what is bond length? Bolo bhaiya, what is bond length? So what we are saying, see, can you see this diagram here? देखो, this one we are saying bond length. ध्यान से देखो, this is one atom spherical, this is one atom spherical. From its center, from here center till here center. देखो देखो देखो, here center till here center, center to center, internuclear distance. This is known as what? Bond length. This is known as what? Bond length. Center to center, internuclear distance. Okay, so I will calculate the bond length. Now in this case, so we are having different atom. One atom is small, other atom is big. For calculation, what I will take, you know, I will take two similar atom. जैसे देखो, I am drawing two similar atom. In 3D also we have. चलो ये तो मस्त है, चलो ये बनाते हैं, लेट्स मेक दिस वन. So this is one atom, and I will take one more same atom. Take a sphere, it is looking like a sphere, good. I will take one more atom, same atom, and I will find bond length, and I will find what? Bond length, and then I will divide that bond length by 2. Then I will divide that bond length by 2. Then I will divide that bond length by 2. Are you getting the point? Not getting? देखो, now you will get what I am trying to say. So I am trying to say like this. यहाँ पे देखो हो गया. So much fun we have done. So this is मान लो one atom. I will take same atom once again. देखो, this is the second atom. Both bonded. Both atom bonded, and now this is the bond length, internuclear distance, this is the bond length. Suppose this distance is 100. I can say कि radius of one atom, both are same. मान लो this is chlorine, I have taken helium, I have taken something like this, ठीक है ना? So radius is equals to what? 100 by 2. Radius equals to what? 100 by 2. This is R, this is R. So we take similar atom. We take what? Similar atom, we calculate bond length, and then we can divide by 2. So like this we will find the radius. Like this we will find the radius. Is it okay? So let's see the definition of bond length once. Let's see the definition of bond length one. By definition and all, NCERT seeing very important. That's why I have directly copied the lines of NCERT. Very important. Everyone able to understand, sir. Similar atom divide by 2. Very good. Correct. Normal common sense, bhaiya. Now see what they are saying, the definition. Definition is bond length is defined as the equilibrium distance. Equilibrium, when it is at equilibrium distance between the nuclei, internuclear distance I told you, between the nuclei of two bonded atom in a molecule. Clear? So this we are knowing now. Okay. And how we can calculate bond length? So methods are there. The bond length are measured by spectroscopy, X-ray diffraction and electron diffraction techniques, about which you will study in the higher classes, which you will not study, I think. Never. Okay. So we are not interested also. Anyhow, you have to solve questions. So the simple point is that you have to keep in mind equilibrium distance. It is the equilibrium distance, or you can say equilibrium internuclear distance. Simple point, equilibrium internuclear distance. And how we can measure it? Spectroscopy, X-ray diffraction and electron diffraction. That's it. So now everyone understood bond length, and everyone also understood that I should take same atom. If I will take same atom, then what will happen, sir? By 2 you will do. मान लो if I take different atom, देखो भैया, if I take different atom, this whole distance is suppose 100, can I do divide by 2 for the radius? बोलो. Can I do 100 is this by 2? No, na? Different atom, bhai. Different atom. Na? You can one child giving 10 rupees, other child contributing 50 rupees. You buy one pizza for this small pizza, 60 rupees. Pizza mania. Will you share half? Huh? Half share karega? Nahin na? Because contribution is not similar, same. Okay. So that's why we don't prefer different atom. We prefer same atom. We prefer same atom. Okay. Okay. ठीक है भाई. So bond length definition you have told, sir. Very good. Okay. So now let's go to the next point. What next point we are having? Ki there are different types of bond. So there will be different types of radius. There will be different type of radius. Like this case which I have given you, This case you can think like metallic radius. This case you can think, heading I can write types of radius. Types of radius, types of atomic radius, ionic radius, many things are there. Chalo, theek hai. So types of radius. So this one you can think, this one I am talking about metallic radius. This distance is suppose x, total distance is x, so I can say x by 2. I can say x by 2. Then you will say that this is metallic radius, then what are the other radius? What are the other radius? So other radius I will tell you, sir, covalent. Covalent compound, non-metal covalent bond is there. Covalent bond is formed by overlapping of orbital. Covalent bond is formed by overlapping of orbital. Okay, na? So covalent bond I am talking now. So in covalent bond what will happen? Batao. There will be one atom like this. Okay? There will be one atom like this. मान लो suppose I am talking about Cl2. तुम ऐसे सोचो I am talking about Cl2. I am talking about Cl2. So one atom is like this. I will take one more atom. आ गया. Now they will try to form bond. Atom coming. Overlap. Bond formed. You imagine here कि here x is 100. You imagine here कि here x is what? 100. You imagine कि x is what? 100. ठीक है? What do you think now? मान लो here we have the internuclear distance. This nuclear distance I am saying y. Can you tell this y is 100, more than 100, less than 100? What is there? Comment करो. Comment y value in covalent case, is it equal to 100, same thing, internuclear distance, or it is less than 100, or it is more than 100? What do you think? Bolo bhaiya. Bhargav. So everyone is agreeing ki sir this is less than 100 na sir, common sense sir. This touching each other, center to center distance 100, overlapping, internuclear distance will decrease. Correct. So this value is less than 100. Correct. Very good. So now I can say covalent radius equals to y by 2. Covalent radius will be what? Y by 2. Assume this is 90. Then this value will come 45. Overlap happening. Okay? Okay. Then there is a third case, van der Waal case. There is a third case, van der Waal case. ध्यान से सुनो. There is a third case, that is what? Van der Waal case. What is van der Waal? So van der Waal generally we are using in terms of noble gases. Generally we can do for all, but we will use this for noble gases. We can use for all, but we will use this for noble gases, because noble gas cannot form bond. Helium, do you think helium sir, covalent bond? No, it is not a metal also. ठीक है ना? So they will try to come closer to each other as much as possible. They will try to come closer to each other as much as possible. ठीक है ना? मान लो this are the atoms. One helium atom, other helium atom. ठीक है ना? Like this. And now what we are calculating again, internuclear distance. मान लो this internuclear distance is Z. Can you tell me what will be the value of Z? 100, less than 100, more than 100? बताओ. Solid. Generally measured in solid form. I will show you all in NCERT also. Don't worry. This though I am telling. After this, I will tell you the definitions from NCERT. I will show you what is written in NCERT. So this is clearly, this is more than 100. So this is what? Van der Waal radius. We call it what? Van der Waal radius. This will be what? Z by 2. Assume this value to be 120. So the radius will become what? 60. Radius will become what? 60. So finally I will ask you, can you tell me which radius is smallest? Then you can say, sir, very easy, sir. Covalent radius is smallest, metallic radius middle, and van der Waals radius is what? Maximum. And you can also say ki mainly used for mainly used for noble gases. Mainly used for noble gas. We can measure for all. Measured in solid state. ठीक है, अब आ जाओ. सो डन, दिस वन भाई डन. अब आ जाओ येलो, सो मच येलो हैपेंड, नो? चलो डन, नो प्रॉब्लम. ठीक है, हो गया. अब नाउ लेट्स सी द डेफिनेशंस व्हिच आर द डेफिनेशंस इन एनसीईआरटी एंड यू विल एग्जैक्टली कम टू नो कि व्हाट इज द डिफरेंस. दिस आई एम जस्ट शोइंग यू, बट लेट्स सी द डेफिनेशंस इन एनसीईआरटी. कहां गया भाई एनसीईआरटी? सी, दिस इज द डेफिनेशन ऑफ कोवेलेंट रेडियस. Everyone read the definition once. Covalent radius. The covalent radius is measured approximately as the radius of an atom's core. Radius of an atom's core which is in contact with the core of the adjacent atom in the bonded situation. This much written. So in simple way I will tell you like this. देखो simple way का मतलब क्या होता है? This is the nucleus, this is the atom having different shells. See, this is valence shell. This is what? Valence shell. Atom can be divided into two parts. One is valence shell and other the rest. Rest part you can say core. Rest part you can say what? Core. One atom you can divide into two parts. One is your valence shell and the rest, all the inner part, you can say what? Core. So covalent radius is saying like this, कि you are able to measure the distance of the core approximately as a radius of an atom's core. Radius of an atom's core. I am able to measure approximately this much. Why? Because some part to overlapping, na? Some part is what? Overlapping. So the radius is coming small. Now they have also shown this diagram. Dekho. This is the diagram. You think like this. This is Cl2 molecule. This is what? Cl2 molecule. Take na, forget this one. Forget this one. You just think about this. This is 1Cl, 1Cl, Cl2. Okay. Now see, they have overlapped. When they overlapped, some part is what? Common. So the distance, when you will find the bond length, when you will find the bond length, ठीक है ना, bond length you will get this much and radius will be till here. So do you think, are you getting the exact radius of the atom? Do you think, are you getting the exact radius? Last some part is missing. So you think like this, कि when covalent bond is formed, na, then core touches the core. One atom core touches other atom core. And you are measuring the distance of the core. You are measuring the distance of the core. Radius, covalent radius. Are you able to get it? So covalent radius, what is there? This much is covalent radius. This is the covalent radius which you will get. And core, I have told you, core, valence shell, I have told you, कि one atom, valence shell remove, rest is core. Valence shell remove, rest is what? Core. Clear or not? So now you can think, कि sir, this much, अच्छा, that's why coming small. That's why coming small. अच्छा, अब आ जाओ twist. Van der Waals radius. Van der Waals. You can also see here. देखो यहाँ पे. You can also see here. This is a complete Cl2 molecule with the valence shell also. This black color circle, na, this showing valence electron also. All covered. This is the core part. Valence shell. valence shell, core part. Now you see here carefully, they have found this is bond length 198 picometer is bond length of covalent bond, and its half is what radius, which is coming 99. So this calculation is still where, from here till here. Originally तो भाई valence shell should come till here. You are not measuring from here to here. देखो देखो देखो, you are not measuring this part. You are just measuring this much. ठीक है? So you are measuring only core. You are measuring only core. But now you see the van der Waal part. Van der Waal radius definition you can check here. The van der Waal radius represent overall size of an atom, which includes its valence shell in a non-bonding case. मान लो you think this is a chlorine atom, then this is its valence shell. Van der Waal radius measures the distance till here. Now I will ask you one thing. Can you tell me, देखो देखो देखो, color से you will come to know कि what is happening. Now if I ask you कि green color representing what, are you able to see? तुम बताओ, लो बड़ा कर दिया. This is one chlorine atom. Everyone see carefully. This is one chlorine atom. This is second chlorine atom. Both overlapping, some part common, ठीक है? Now can you tell me what is the green color representing? बताओ, green color is representing which radius? Final part. After understanding everything, I am asking you the final part. What is the green color representing? Everyone reply, everyone try to reply, then we will come to know na ki bhai you have understood or not. What is green color representing? Green color is representing core radius, or you can say covalent radius. What is pink color representing? बोलो, अब बोलो कि what is pink color representing? Pink color, overall atom size from the nucleus till the valence electron, till the valence shell, from the nucleus till the valence shell, है ना, in non-bonded form. Non-bonded form means this is the chlorine atom, so you have measured from here to here, full. From center till valence shell you can say. So this is the difference between covalent radius and this. Can you tell me what is this? ये बताना मेरे को एक बार. You tell me what is this circle? This violet color or whatever. What is this circle? What is this circle? बताओ, nucleus or core? Core. Don't say nucleus. Core. This is what? Core. Nucleus plus inner shells. ठीक है? That means they have divided the atom into two parts. ठीक है ना? This is the valence shell till here, nucleus and the inner core. ठीक है ना? From center till valence shell, van der Waal radius. From center till the core, covalent radius. Clear? And all the points are now written here. ठीक है ना? Further, the van der Waal radius is half of the distance between the two similar atoms in separate molecule in solid. In solid. This only they ask you. So in solid. 1 Cl2, 1 Cl2. ध्यान से देखो. अरे सब इधर उधर हो गया. ठीक है ना? If in one molecule you will find, you will get covalent radius. If in one molecule you will find covalent radius, one molecule, separate molecules, find the internuclear distance, ठीक है ना, which will include the valence shell also. So van der Waals radius is half of the distance between two similar atoms in a separate molecule in solid. ठीक है? So this is the point of van der Waals. All the definition you must see. All the definition you must see. So I have highlighted few points mainly used for noble gases, measured in solid, and you can also write here from कहां से कहां तक बताओ? From nucleus till valence shell. Valence shell. And here what you can say कि this is radius of core. You can say कि this is radius of core. This is what? Radius of core. Clear? Done. That's it. All the definitions I have shown you. All the questions we have done. Questions we have not done. Sorry. Questions we have not done. But we have told you the difference between these three radius. Definitions we have shown you. And this diagram, we can ask you this diagram only in the paper. ध्यान से देखना. This diagram I can ask you in the paper. ठीक है ना कि what is this representing? We will write here 198. देखो how they can ask you. Will everyone see? How we can ask you in question paper na, based on that diagram. See how I can ask you that diagram in the question paper. Everyone see here carefully. I will copy this diagram. ठीक है ना? I will copy this diagram in your paper. I will copy this diagram, and this I will not write. I will write कि भैया this one is x. And this one I will write कि this one is y. ठीक है ना? You have to tell what is x and y. What is x and y? Find x, y. Find x, y. What you will say? So you will have to understand here this x is just the distance from here to here. So this is covalent radius. And y is, check the y. What is y? Y is a distance from here till here. So y is van der Waals. Y is van der Waals. Y is van der Waals. We can also ask you like this from here. From here to here which distance is there, and from here to here which distance is there. So you can say this is covalent and this is what? Van der Waals. This is covalent and this is what? Van der Waals. ठीक है? Not color, not there, no? देखो, that is covalent, this is van der Waals. You can think like this. ठीक है? So that's all. So this is about the radius which we have tried. Other question also we can ask you. We will give you this distance and then we will ask you कि tell me. देखो. Second question from the same diagram. From the same diagram. Again from the same diagram. ठीक है? We'll modify now. So everything is visible to you. But at that time, what we will do, you know, we will not give this part. We will not give this part. We will give this much. And the question is, Find covalent and van der Waal radius. Find covalent and van der Waal radius. These all things will not be there. ठीक है? Clear? In solid form generally we should measure so that we get a bit accurate. हो गया खत्म. So we'll have to do like this कि this is the internuclear distance for van der Waal. So you will do कि van der Waal radius is 360 by 2 and covalent radius is 198. This is internuclear distance of the core distance na, core part. So 198 by 2. ठीक है? Done. That's it. Now let's see the trend in a periodic table. ध्यान से देखो अब यहां पे क्या क्या बोल रहा है कि factors affecting radius. Factors affecting radius. First we will talk in a periodic table. In a periodic table. So we know कि if you go left to right in a periodic table, size decreases till halogen. Size decreases till halogen. Then you can say कि sir why you are writing till halogen? You can write complete na, size decreases. Why we are writing this? Because at last what will come? Noble gas will come. In noble gas we measure van der Waal radius. So that radius can be bigger. So that's why we are not telling. So we are doing till halogen. In NCERT they are writing that we should not compare van der Waal radius with covalent radius. If you have to compare everyone's van der Waal. Or if you have to compare, then compares everyone's covalent. Don't compare one covalent other van der Waal. Like this they are saying. Like suppose two students are there, A and B. I am comparing this child re-NEET 2026 bio marks. And this child I am comparing physics marks. Bio में चलो you will say sir 360, this तो 180. चलो भैया zoology marks. This child will say sir I got 175. This child will say sir I will get 80. So what we will say? कि this child not studying. Comparison is wrong. Comparison is wrong. You should compare both person botany marks, geology marks, or both person physics. Same comparison should be there. So this comparison is only not correct. Ki you are comparing covalent bond radius in halogen with van der Waal radius of noble gas. So that's why we'll follow till here. Acha, reason what you can say? Anything happens in a period. Reason is simple, as Z effective increases. Acha, what will happen down the group? Down the group you can say size increases. Last class I have told you as extra shell added. As extra shell added. Last class, last 5 minutes you can check. Okay, let's come to the second part now. Second part what we are saying, shielding. Shielding increases, then what happens to size? Shielding increases, then what happens to size? Shielding was what? One shield coming. So between the electron and the nucleus, between you and me, shield is there. So what? I cannot attract you. So you can say shielding increases, that means Z effective decreases. So the size will increase. So the size will increase. Third point you can say ki as positive charge increases, I will explain this to you, as positive charge increases, size decreases. And second point you can say, last point, ki as negative charge increases, size increases. Okay? So this point you see, then I will talk about the next one. Okay, positive charge and all, what is happening? Positive charge, negative charge, what is happening? This we will tell you. So whenever we are talking about positive charge, negative charge, that means we should quickly jump to ionic radius. We are talking about ionic radius. We are talking about what? Ionic radius. Now you can say, मान लो if I ask you size of Na plus and Na, size of Na plus and Na, देखो how to compare size of Na plus and Na, cation and parent atom, positive charge more, no positive charge, cation and parent atom, बोलो who should be more? जल्दी बोलो, who should be more? Everyone should be active. बोलो भैया cation और parent atom, who is bigger? That which one? Parent atom is what? Bigger. How you can compare? You will say simply, sir, proton. Can you tell me the number of proton? You will say, sir, 11. Array, positive charge affects electron. Charges affect electron. Proton is sitting in the nucleus. ठीक है ना? You cannot do to the proton anything. अच्छा, what about electron? Electron, you will say, sir, here 11, here 10. One electron gone. अच्छा, one electron gone, you can say कि sir, number of electron decreasing. Number of electron decreasing means what? You can say, sir, repulsion decreasing. Electron repulsion, big size. Attraction, less size. Electron gone means repulsion is less. Repulsion is less, that means what? Attraction is more. Attraction increases, you can say Z effective increases, that means size decreases. So cations are smaller than parent atom. I can conclude now, cations are smaller than parent atom. I can also say like this, which you have already said, कि as positive charge increases, size decreases. Can you tell me the size of A plus 1 plus 2 plus 3 and A? Bolo, who is bigger? A plus, A2 plus, A3 plus. Who is bigger? You will simply say, sir, A is bigger. As positive charge increases, size decreases. Okay. Now reverse of this you can do on your own. Something I have told you, something you will do on your own. Second point, these are easy things. Cl minus. Bolo, who is bigger now? Who is bigger now? Anion. You will say why? Proton increased. Huh? You will say no, sir. Electron increased. And if electron increases, number of electron increases. That implies repulsion increases. That implies Z effective decreases. Attraction decreases. That implies repulsion more, size more. So what you can conclude कि anions are bigger than parent atom. You can also say कि as negative charge increases, A minus, A2 minus, A3 minus, who is biggest? बोलो भैया, who is biggest? A3 minus. Who is biggest? A3 minus. So now let's do some questions quickly. H plus, H minus. Can you arrange on the basis of size? Now let's do 3-4 questions. Fatafat. Quickly. Nah? Because these are basic things I think you have studied. Anyone having any doubt in this, you can ask. Cl minus. So you will say, sir, this one to parent atom, this one cation, sir, this one anion, sir. Anion is bigger than parent atom and cation is what? Smaller. Same question they can ask you in different way. Ki if radius of potassium is 134 पिकोमीटर, या लिथियम का, चलो लिथियम बोल दिया, लिथियम इज 152 पिकोमीटर. फाइंड रेडियस ऑफ लिथियम आयन. And your options are 122, exactly 76, 160, third option 152, fourth option 200. Picometer, all are picometer. Bolo, what is the correct answer? Bolo, bolo, bolo. Acha, many people now ask here one thing. देखो, some people use brains. They ask, sir, you have mentioned lithium ion, sir, cation or anion, sir? अरे, you will have to think on your own. Lithium forms cation or anion? बताओ तो तुम. Lithium forms cation ना भाई, metal. So that means I am talking about metal. So atomic radius given, atom radius given, I have to find cation. Cation should be what? Smaller. Only one value is small. Only one value is what? Small. Very good. A few same people only writing answers. Why everyone should write? Chalo. So slowly we are increasing the level of question. Aajo, third question. Third question they are saying like this, ki if, so quickly we will do some question. If K plus F minus is equals to 1.34 angstrom, size is similar. देखो, if size of K plus F minus is similar, find size of K and F. Find size of K and F. Chalo, I am giving you values 1.22, 0.76. रेस्पेक्टिवली भी लिख लो. Other value I am giving you 1.34, 0.76. Other value I am giving you 1.54, 1.1. And next value I am giving you 1.7, 1.4. चलो बताओ which one is correct answer. Now this question is a bit better standard. ठीक है ना? This question is a bit better standard. You will have to think on your own. बोलो भैया. अखिल, सना, आरिफा, मोहन साई, भार्गव, वरदान, तुलसी, सुदेशना. बोलो. Which option? So how to do this question? You should think like this, K plus and F minus size 134. We have to find for K. So you think like this, K is bigger than K plus or not? Yes. And K plus size 1.34. That means K value should be more than 1.34, which is having option. These two. Two options are there. Okay, then you have to think like this, ki F and F minus, whose size is smaller? F is smaller. This is 1.34. That means F value should be less than 1.34. So this is the value less than 1.34. C answer correct. C answer correct. So see, quickly we have done 3 questions. Okay, chalo, again we will move to easy question. Easy. So this time you have to tell me the size of fluorine, chlorine, bromine, iodine. You will say, sir, this is very easy, sir. Down the group size increases. Then I will give you this question then. Beryllium, boron, carbon, nitrogen, oxygen, fluorine. You will say, sir, this also easy, sir. In a period size decreases. Easy. Then I will give you the size of ऑक्सीजन, फ्लोरीन, क्लोरीन, phosphorus, sulfur. अब बताओ how you will compare this one. बोलो, tell me the order of this. So before this given na bhai, this question given, do so which one is bigger? So you should, how you should solve this, because this is not in a period, not in a group. Some are in a period, some are in a group. अब बताओ. So first of all, you should arrange it in a periodic table. Ki where it is lying, like oxygen is here, fluorine is here, sulfur is here, chlorine is here. So this one is bigger, this one is bigger, this one is bigger, this one is bigger. ठीक है ना? So it is looking कि sulfur is biggest and fluorine is smallest. What about oxygen, chlorine? So you remember one thing कि generally the diagonal elements are bigger. Generally diagonal elements are bigger. Generally diagonal elements are bigger. So I can write ClO. ठीक है? This is the answer. This point we have to learn from here कि generally diagonal elements are bigger. Generally diagonal elements are bigger. Generally diagonal elements are bigger. Generally I am saying. ठीक है? So now we are going to do the last topic. ठीक है? So last size comparison we are doing. Last question. Last question in size. Now what I am telling you, कि मान लो suppose you are having S block. Suppose you are having S block. Everyone knowing कि sir S block ना lithium, sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, strontium, barium. Everyone knows कि sir in a period the size decreases sir. What is new in this? Down the group size increases sir. What is in this? As everyone knowing. In a period knowing, down the group knowing. Can you compare the size of all elements? I have written here 10 elements. Can you write me the order of all 10 elements? Bolo bhaiya, can you write the order of all 10 elements you can compare? Can you compare lithium, barium, potassium, cesium, strontium, everything? Can you compare? Batao. Tell me the order if you know. And from after today you will come to know it. And you will never forget also. Batao. Last question for today. Last. After this, we will start new topic. We'll start with ionization energy a bit. ठीक है? थोड़ा सा तो पढ़ लेगा. अच्छा, exceptions of radius and all I am not telling you much because that we don't require. I am just telling you some basic points which we will use in bonding chapter. Which we will use in bonding chapter. Okay? Those who have missed the last lecture, Z effective was taught. That was the main topic of last lecture. So you can see the last video on YouTube. You can tell your friends also. Any friends, share the video with them so that they will be also benefited. Don't be selfish. So what I should tell? Bolo bhaiya. So there is a simple method. What simple method is there? See, lithium, beryllium, you know lithium is bigger. This to we know na bhai, in a period size decreases. This we are knowing. So start from here like this. Then go like this. Generally diagonal elements are bigger. Then again go like this. Then again go like this. Again you can see, sir, generally diagonal elements bigger, sir. Correct. Then what? Go like this? No. Then go like this. Then go like this. Then do like this. Ho gaya, khatam. So now can you tell the order? Now it's very easy, bro. Beryllium, lithium, magnesium, sodium, calcium, strontium, barium. Barium के बाद potassium, rubidium, cesium. Cesium is the biggest in S block. Ignoring seventh period. Seventh period we have ignored. Clear to everyone? So something we have learned today at least. Anyone will ask me S block size, I will tell very easily, confidently, correctly. Is it okay? Bolo bhaiya, correct or not? Is it okay? Okay. So let's move to the next part. That is ionization energy. Ionization energy, ionization enthalpy. We'll also tell you what is the difference between ionization energy, ionization enthalpy. For now, so you understand that both are similar. Similar, but not same. Okay? So ionization enthalpy. Bolo, do you know the definition? So share with your friends, tell them, bhai, join quickly, learn something, don't wait ki re-NEET marks and all is free na bhai, free going on online. Why to miss? Why to waste time? 1 month will be wasted if you wait for the results. ठीक है? ठीक है ना? So you are at home, eat nicely, watch nicely, study something, revise something. What will happen? No one knows. Those who are sure कि भाई my to selection done, college I am selecting only, then fine, enjoy life. But those who are on the border and those who think they can do better, ठीक है ना? Don't waste time. At least by the time when it is getting free, those lectures we should must attend. We must attend those free lectures. After that we will see what to do. But free, so we can free things. Who leaves? Chalo, aaja bhaiya. So definition you have to read nicely. It is not like this only ki sir remove electron. We will write like this ki it is the energy required to remove an electron from valence shell of an isolated gaseous atom in ground state. So many points we have written. This much big definition. Okay, na? Okay, so few words I will underline. Like it is the energy required. It is the energy required. Required means what? It is endothermic process. This is endothermic always. Delta H value, bhaiya, negative or positive? Positive. Clear? So, to remove an electron, from where you will remove electron? Valence shell, from outermost shell. ऐसा नहीं कि you are going near the nucleus and removing from there. From outermost shell. Isolated gaseous atom should be there. And it should be in what? Ground state. So 4 words important. Okay. So in NCERT question is there. Why isolated gaseous atom? So that there will be no effect of other atom. In gaseous phase, the interatomic forces are what? Weakest. Intermolecular forces, interatomic forces are what? Weakest. So one atom will not affect other atom. One atom will not affect other atom. Suppose I have to beat one child. What do you think when I will beat him? मान लो एक बच्चा को मारना है. I want to beat one child. What do you think when I will beat him or her? Her also I can beat. Gender equality is there. ठीक है ना? So when I will beat him? बताओ. I will beat him when he is with his friends. 10 friends are there. He is sitting in middle and then I will go and beat. Foolish people. No. I will find one place where he will be alone. No one is there. ठीक है ना? Then I will beat him. Isolated case. ठीक है ना? Isolated case. To be more secure, I will also do this thing. I will beat at night. I will wear night vision goggles and then I will beat. I will see him, but he cannot see him. ठीक ना? So that's the best time. So this is isolated also and gaseous atom also. Clear? So let's write some reactions. Now people will give you this reaction. You have studied ionization energy. Batao, this is Na sodium. Sodium will take one electron. We will remove one electron. Is this reaction representing ionization energy? Batao. Is this reaction which I have written here, is this representing ionization energy? No. Because you will say, sir, solid you have written, sir. It is not solid. Here you can say that delta H not equals to ionization energy of sodium. Okay, you want gas? Don't worry, I am giving you gas. Na gas will give rise to Na plus aqueous plus one electron. Lo bhaiya gas de diya. Now is delta HR equal to ionization energy of sodium? Again you will say, no sir, don't make us fool. This side gas, how it is becoming aqueous? Both side we should have gas. So इधर लिखेगा Na gas, this side Na plus gas plus one electron. This is ionization energy of sodium. So energy required to remove one electron from isolated gaseous atom. So gaseous atom will become gaseous ion. This is ionization energy definition. Questions are based on this also. Which of the following? They will give you three options. Which of the following represents ionization energy? Which of the following represents ionization energy? Which of the following represents ionization energy? Clear? Done? So last one. It is the energy required endothermic. Okay? Then we can tell you factors affecting and all that we will tell in the next class. No? So enough for today. You can also revise on your own. If you are thinking these things I already know, then open your previous notes, read everything from there. Whatever you feel ki this point I don't know, this point I don't know, you can read all those points. Okay? And you can do some questions also, because you are not a class 11 and 12 kids, na? Okay, these topics are new to you, you are not familiar with them. Okay? All these topics you are knowing already. Okay? They will teach initial few lectures, they will teach on YouTube free. Then they can switch to app. So bhai jab tak free hai tab tak to maje lo yaar. ठीक है ना? चलो. So it is like this. Next class I am writing here only ki what we will talk about next class. I will give you first one homework for you ki मान लो suppose ionization energy 1 is there, ionization energy 2 is there, ionization energy 3 is there for any atom. Then what is the order of ionization energy 1, 2, 3? ठीक है ना? Tell me the order. And next class we will start with factors affecting ionization energy, ionization enthalpy. And we will write the simple points. Okay, so take the QR code. How to enroll? भैया कॉल करो और क्या, नंबर they have given you so many online videos going on daily कि like this you can call with him, you can call, so call, Google मारो gosalite.com, ठीक है, there you will find our photo, you will get confirmed कि अच्छा this is the institute. Okay, understood? So now though you might be having so much time na, huh? Oh, you are watching only these things only, where counseling going on, what is the cutoff marks, 3 days you are seeing these cutoff marks only everywhere, you are comparing that institute giving this institute giving that, that institute not good, this institute bad, so much online content also coming. Don't waste your time in rubbish contents. First qualify NEET, then you can watch. ठीक है, someone is saying कि E3 is more, reason also you will have to give. ठीक है, तो चलो fine, done, take the QR code, that's it for today. हो गया भाई, चलो, thank you everyone, bye bye.